Welcome back, ladies and gentlemen. In this video, we are going to show how to prove that triangles are similar by side-side-side similarity. Within this section in general, we're going to be identifying the side-side-side and side-angle-side similarity theorems and use them how to show that triangles are similar to one another. In this video, we're going to define side-side-side and use it to prove that triangles are similar. So let's talk about the side-side-side similarity theorem. We're basically just saying, hey, if you can show that each of the corresponding sides are proportional, then the triangles are similar. All right, let's break that down a little bit more so. If I can show that each of the ratios of our corresponding side lengths are equal to each other, then the triangles are similar. All right, you're still saying that doesn't make any sense. Well, all of these ratios that we're actually finding, what are they? Those are the scale factor, folks. So if I can show that the scale factor is equal in all three corresponding pairs, then my triangles are similar to one another. Because that's what it means to be similar. They have the same scale factor. They are enlarged or reduced proportionally to one another. So let's look at an example. It says either DEF or GHJ is similar to triangle ABC. So we're asking yourself, okay, we know that this is a focus triangle ABC, and then it says of DEF or of GHJ, which one is similar? Well, it's all going to be depending on which one will have the same scale factors or the ratios equaling every single one. So let's go ahead and do this. What I like to do is I like to break this apart. I want to break this apart into the small size, the medium size, the middle, and the large sides, right? And we're just going to compare. We're just going to compare and make sure that each of them match up. So if I'm comparing ABC to DEF, this guy in the middle, so let me kind of just put some little boxes around this. This is my focus right now, right, is DEF. So which ones match up here? Well, of course, this one's pretty simple because there is color-coded on everything for us. But of course, we can always look at the names of the triangles to see how the letters correspond. AB matches with DE. So AB matches with DE. And what does it equal? It equals 8 over 6. And last time I checked, 8 over 6 equals 4 over 3. So if this is going to be similar, that means the middle ratio has to equal 4 over 3, and the large ratio has to equal 4 over 3 as well. Let's take a look at the middle ratio. The middle ratio is what we see here at BC and EF. So BC is to EF. And what would that equal? Well, that equals 12 over 9. Well, once again, last time I checked, 4 goes into 12, excuse me, 3 goes into 12 4 times, and 3 goes into 3 9 times. So 4 over 3. And last but not least, the large sides is AC over DF. And what do we see here? Well, that ends up being 12 over 9. I'm sorry, 16 over 12. I'm sorry, I'm going back to the other one. 16 over 12. And once again, 4 over 3. So what does this mean? Since each of these equal each other, I can say that by the side-side-side similarity theorem, these are all similar triangles. Okay, so these two right here are similar triangles. ABC is similar to DEF. So I'm going to write that down. Triangle ABC is similar to triangle DEF. So now I will do the exact same process, but I'm going to focus on this triangle now, GHJ. So I will compare the small side. So AB and AB is to HG. Actually, it'd be GH, to say consistent. And so that is 8 over 8. Well, that equals 1. You should hopefully at this point start to notice that we're going to have an issue here, but let's continue and go on just in case. So if this is going to be similar, that means small, the middle, and the large sides will all equal 1 for the scale factor. But what really does that happen? If they all equal 1, are they similar? No, they're congruent to one another. So what else do we see? We see that BC we see that BC is our middle side, so that's 12, is to HJ. So 12 is to 10, and 2 goes into 12 6 times and into 10 5 times. And so clearly 6 over 5 and 1 are not equal to each other. They are not going to be similar in